Topic of today is deploy bare metal Kubernetes on Equinix Metal. That's really a topic, and I'm very happy to see that the folks before also on presenting work around Kubernetes. So that's very cool. Quickly, an introduction to my person. So yeah, my name is Engin Diri. I'm working as a customer experience architect at Pulumi, and love everything related to cloud transformation, enablement, and everything around CI and CD. So if you have any questions around this, feel free to reach out. You will see some of my socials underneath. So feel free to reach out if you have any questions. Okay, so the subject is demo day, but still a little bit theory behind, I thought could be quite useful. And one very quick introduction I would like to give is why we are doing infrastructure as code. So what is the thing around this? So here we can see a typical setup. So we have on the left side, we have a person working on different cloud providers on the top, as you can see, and then using a ClickOps approach, for example, or going through the console of the cloud provider and clicking through and creating some infrastructure, in this case, a database, a Kubernetes cluster, it could be everything. So that's the way to go. Nothing wrong with this way. Nobody says, hey, this is completely forbidden. Everybody starts using the console or doing some kind of ClickOps. Depending on the level, it's completely fine. So this person works on this, created, and now people inside the company and reach out and say, hey, we would also to deploy on a Kubernetes cluster. And we also need a database or additional resources. So everybody goes on their system and start to create the Kubernetes cluster. And now you can think about this. When everybody goes and clicks on something, it could be that one cluster is not set up the same way or according to the standards or whatever you have inside your company. And things get a little bit too fragmented. So you have a cluster with 4 nodes, and you have a cluster with different node settings and so on. So it gets quite messy. And now think about this. It's not only that you work with one stage. So depending on your project, you have maybe multiple stages. So you're having a productive stage, several pre-prod stages and development stages. And think about this. You have to click or create or CLI it every time from scratch. So this is something where you say, okay, is there not a better way to handle the situation to avoid that maybe one cluster looks differently? There you also maybe heard the term of this typical pet clusters, like your pet at home. It has a name and you treat it and so on and give it special care. So here comes now infrastructure as code in place. So instead going directly to the console or using whatever system you have, for example, a CLI or the UI, you can now create infrastructure as code. In this case, with Pulumi, the different teams can use Pulumi to create the definition of the Kubernetes cluster, whatever resource they're using. They have it everything inside as code. They execute then Pulumi, so Pulumi goes then to communicate with the cloud provider APIs to provision the infrastructure. And as soon as the infrastructure is ready, or any state, any operation you did on the cloud side, the state gets saved. So Pulumi saves a state and compares every time when we run a new Pulumi command against our code and against the cloud provider. It compares and say, hey, is the thing I ordered already, for example, the Kubernetes cluster, is it still the same like I declared it here inside my code? And if there is a drift, for example, we see that still somebody clicked his way through the UI and changed maybe some setting, you will get an alert, you will get a notification inside your Pulumi run, and then you can decide, should I continue? Because it's a minimal thing and I just want to say my single point of truth is the Pulumi cluster, or should I cancel the update because it's an inversive change. Some of the resources needs to get destroyed and recreated if you change something. So is this something I really would like to do? So getting feedback, having everything in code, and now you can see you can easily scale this up. So write once your definition, and then when everybody comes, you can say, hey, listen, I already created the perfect setup for Kubernetes. here's the code, check it out, or use your internal developer portal, and then you can cookie cut and bootstrap this piece of code and just change the properties you would like to change. And as a goodie, what we can now also do, because we have everything as code written, we can now enforce policies. There are different ways to enforce policies. In Pulumi, we have crossguard, so you can write policies and then execute them also automatically against your code every time you do a change. So you can now really 24/7 take care that nobody can provision a Kubernetes cluster with GPU just for the loads. So this is one setting. So have a look on the history of infrastructure as code, or the evolution. So we have our manual thing, what I said at the beginning, so ClickOps through wikis, or playbooks and everything set up. So nothing, again, I'm not judging here, nothing is wrong with this approach. And you see there is something missing, the person, the one person who knows the stuff. So the one guy, I called it here. Everybody has this kind of person inside the company who is just in charge of the thing. So you don't want to become this person everybody's calling because they need new piece of infrastructure or whatever, and then you have to go through and create the stuff. So that's the manual part. And then we come to the imperative part, where we use things like Bash, Python, Puppets to create here our infrastructure called here the procedural automation, or maybe you use the CLI of the different cloud provider, put them in a specific order, create this one, and then the moment the resource is created, you then continue with the next one, and maybe have to think about some failover mechanism, retry stuff, and so on. So that's the point here. And now we come to the declarative place, where we can say here are tools, just as an example, Pulumi, OpenTofu, or Terraform. We have Crossplane. We just saw this before with Jared's talk. And this is the thing where we would like to reach and say, hey, there should be a point in the company where everybody should have a declarative approach, whatever tool is it, and manage their infrastructure over this way. Okay, so we talked about the benefits now. I just put them again. Cost reduction. Yes, of course. Speed is always money. Engineering time is the most expensive one, and we don't want to spend that. Every team creates their own deployment. We then get, in any case, increase of speed and deployment, which is very, very important. We reduce errors because, yes, everybody makes errors. We are humans. So clicking on one button, accidentally forgetting, for example, setting up a firewall rule or whatever, and boing, you have an issue. You also increase your infrastructure consistency. That's very important. So stages look similar or are 100% similar depending on how you would like to set up the stuff. And of course, you can here eliminate also configuration drift. You can run now your program. We just heard from Jared with crossplane, getting the configuration as part of the reconciliation loop, or running Pulumi here with different functionalities to then detect drifts and give you notification. So have a look on the list, because now I would like to give you a short introduction to Pulumi. And then I will bring up the list again, because we want to add one point additionally here. So, okay, again, I want to keep this as short as possible. So what is Pulumi? So here are some of the points I really, really like to explain Pulumi in a very high level view. Yes, of course, there are many, many things we cannot cover here in this call. So Pulumi is modern infrastructure as code. Pulumi is using familiar languages and tools. So you can, for example, if you already have a background in Python, for example, or you have a background in TypeScript or Go, you can just continue using the language. You can continue to use the IDEs and all the value chain you created by delivering, for example, business value application logic to your runtime. You can just continue. So there is no switch in context. You don't need to learn new tools. You don't need to learn, for example, a specific setup. Continue and leverage what you already have. What's also very important is here, it works with any major cloud provider. So there's a huge ecosystem behind this, which is very important if you want to create, for example, as part of your platform engineering story, you want to create some end-to-end stories, provisioning GitHub and then continuing and then deploying and so on as part of the cookie cutting. It's possible with all the recent changes. it's very important to mention also that Pulumi is open source, so you can use it. You don't need to pay any money. Just continue. You can use your own state handling and use a bucket and a S3 bucket or any GCP bucket object storage. So completely up to you. Of course, we also offer here a cloud solution. There is a generous, I hope I said it right, free tier. So I'm using, for example, even I'm working at Pulumi, I'm still using my private organization. That's very cool. And then I can, don't need to think about any state handling and get some of the benefits of the cloud. And yeah, there are some points. If you have, for example, any restrictions on your company side, like, hey, I cannot use the cloud for my infrastructure, there is also a self-hosted version of Pulumi. Okay, so here are the three pillars I always like to show. So we have on the left side, we have our build pillars. You can see all the languages we are supporting. And then you see, because it's a programming language, you can just use your IDEs, your package managers, and your tools you already have. For example, we have engineers at Pulumi. They use Vim, for example, for programming. And it's always funny when they share the screen, I see Vim, and then they run, for example, the Pulumi code. So yeah, you don't need to change anything. The middle part, all the providers, it's very, very important, as you can also see, the Equinix provider. And on the right side, yes, it embeds itself very easily into your existing tools. For example, if you have a Jenkins, if you have Azure DevOps or GitHub in place, you can just continue add an additional step in your pipeline, for example. We also offer a Kubernetes provider operator. So you could then deliver via GitOps, for example, Argo CD. You can deliver then the definitions of your Pulumi programs to your Kubernetes cluster and then roll it out, which is very interesting for the people who say, okay, we would like to use Kubernetes as our control plane, as our main platform. Okay, so I mentioned before, Pulumi consists of many, many sub products, sub tools. So let me do like this. So we mainly focus here on the demo now on the Pulumi IAC part, and then also using the Equinix provider. But as you can see on the left side, there are some additional things like the Pulumi Kubernetes operator or Pulumi automation API, where you can programmatically execute Pulumi code inside your REST API, inside your CLI. That's very, very cool. So people create really their own operator because they have a specific use case, and crossguard and so on. So huge thing. What does it look like? You will see this also in the demo, but here just an example for different languages. So here I created with the Metal Equinix provider, I created here a new project, one of the easiest resources. So this is the version how it would like in Go. Yes, I'm an Go developer. I really like Go, so this is the way it works in Go. Same code, same creation here in TypeScript. So, and in Python, for example. And now comes the clue, and we will also see this later. We also support YAML. So YAML is a fully supported language in the Pulumi world, and this is the same code or the same creation of the resource using YAML. Okay, yeah, that's very beautiful. I mean, I like it very much. I hope you appreciate also the idea behind this. And now we bring up the benefits table again, and we see, yes, cost reduction. You see now, using your IDE, and you're getting the squiggly lines. If you have something wrong written, you get the autocomplete of the IDE to see what functions or what methods are inside your cloud resource you can use. I mentioned speed of deployment and of development, yes, because you use your IDEs, you continue your IDEs at the end of the day. And I put now air quotes here. For a developer, it's just an additional library. It's something people know when they have a programming background. Yes, of course, you need to know what you're doing. You may need to follow some architectural guidelines. You have to work maybe, or you have to do some certifications around what you're doing at the cloud. But then the execution feels more like including a library. And of course, reducing errors. We always heard about this shift left, getting the feedback on the as soon as possible. And then because of no overload and changes and so on, you just reduce the errors. Pulumi loves Equinix, that's for sure. So we have also an Equinix provider. There's also an Equinix Metal provider. This one's deprecated, so there were some changes from Equinix. But yeah, you can use Equinix. Just head to our Pulumi registry. Okay, now comes the biggest question. Everybody see, yes, programming language, programming, Engin mentioned all the time, something with programming, yes, there's YAML. So, but what happens when I'm not a developer? How can I start using Pulumi? So again, here our escape hatchet, I call it now escape hatchet, but at the end of the day, it's a fully supported language which has the same functionalities. You can use YAML as a start. So creating your definition of your cloud infrastructure in YAML, and then with the command Pulumi convert, you can then use this YAML to create specific programming, the versions in the specific programming language. So think about, you maybe decide later on, hey, I'm fine, I can continue now with a programming language, or we all decided to use Go. Yeah, then just convert your YAML file into Go and continue from there, deprecate the YAML one, and then just continue with the Go version. Because at the end of the day, when you run Pulumi up, the graph which gets created, it's independent of the programming language you're using. That's the neat part. So whatever fancy stuff you do in the programming, it just creates the graph and compares the graph with the state. Or I like choices, and I think Jared also mentioned this before. Yeah, stay in YAML and just add additional value to it. So you could use KCL, you can use Q, and then the Apple stuff pickle. Just use this approach and then give some additional logic using this config management languages on top of it. And yeah, stay in the world of YAML and continue with this. So that's also a possibility. Okay, enough with the theory part. If we don't have any questions so far, I'm very open to questions, then I would like to switch to the demo. I put the QR code there. I put the GitHub link where you can see the code and you can just try it on your own. And you can see the repository name is very, very long. So I will stop sharing. Do we have any questions so far?
I think, why don't you jump right into the demo and then we can revisit any questions if we need to do that later.
Perfect. So that's completely fine. So then I stop here because I can share little windows. So,
yeah, perfect.
So let me share my screen here. Okay. So I go now to
that looks great.
Where are you? Workshops, and then create a Equinix test. Okay, now created here my folder, and then I downloaded the Pulumi CLI. It's already installed here. You can homebrew it, or depending on your operating system. And then I can say Pulumi new, and the story starts here. So now we have several approaches to work with this. We can use pre-existing templates. We can use templates maybe our platform engineering team already created. So that's something possible here on all the sites. Or we can use AI. So you could create with natural language. You could say, hey, please create me a cluster in the provider XY, and then it will create you with as much as hallucination eliminated as possible. Will give you a bootstrapped project you can instantly then also deploy and use as a scaffolding. Okay, we go to the template. If you're not providing any templates from your side, it will use some of them we created. And of course, we have also some templates with Equinix. So when we use now, for example, Equinix, let me use Python, then giving a name. Oops. I have already, so we say demo the Equinix, bam, giving a stack name. I'm not talk too much about the details now, what is a stack in Pulumi world and so on. So I think that's completely fine to work on this. And then it installs everything from here, in this case, from the public pip PyPy repository. If you have an Artifactory, you can point to your Artifactory. I think you know this. And let's see. Now the files are created, and I can just continue to create the stuff I would like to change. So I will not continue with this one because I created another demonstration that's more valuable. Okay. So let's see the real code, because now I want to create something bigger. So I share also this screen. Okay, I mentioned before I'm a IntelliJ user, so sorry for this one. So here I created now in TypeScript. I created here the project. So as you can see from the TypeScript base, I have my package.json. Again, from npm.js, I include now the Pulumi and the Kubernetes packages inside. Because now comes the clue. I'm not creating now directly using Pulumi Equinix resources because I would like to use the cluster API. So there is a cluster API provider from Equinix. Let me share also this one. Maybe it makes sense. Where is my Chrome tab? Okay, here's it. So there is a cluster API provider. I will not go into details about this because I had a peek look into the agenda, and there's somebody talking also about the cluster API provider. I'm not talking too much about this, but there is a way where we can now create and deploy the cluster API operator on a Kubernetes cluster, and then use this one to create additional mesh virtual machines on Equinix and then connect them automatically using kuberdm to a Kubernetes cluster and get the kube config. So that's the thing I would like to deploy, just to give you the context. So making here the big switches. So we go back again to our code. Where are you? So because here, that's the reason you don't see now the Equinix provider, because I'm not going to create now via Pulumi Equinix resources, but we use Pulumi to deploy the cluster API. So let's have a look. How does it look like? And I tried also to use as much of the resources and different resources we have here in the world. So Pulumi is not disconnected from existing ecosystems. So people will be like, hey, does it mean I need to create all the third-party Helm charts on my own? And so, no, you don't need this. You can just use here our Helm release object or Helm release resource and just define all the properties. In this case, I say, hey, I need the cert manager. I can say the specific version. I can make the version variable and so on. It depends, again, on your style. So I'm going to install the cert manager. I can create programmatically also additional Kubernetes providers. So think about you have maybe a Kubernetes config with a specific service account with lower rights and all this stuff. So you could provide this. There are, and now we come to the squiggly line, as you can see now, different properties, but I could also set here the kube config. So if you have access to the kube config through a way, you can just point to this kube config. Maybe you get it via systems like Teleport or whatever, and then you can use this one. So creating programmatically additional providers. If you don't set up, as you can see, a provider, it will take the default from your kube context. So as you can see, I'm using the Kind cluster as our bootstrapping cluster. So it will automatically detect the set cluster context, but I could also set a specific provider here and then also enable some, as I mentioned, kube configs or server-side apply and so on. Another point is then here, I can point to existing manifests files. So for example, the copy, it's a huge thing. So I'm not going to write the copy stuff again in a programming language or something like this, because I don't want to own this. Maybe there is an update and so on. So maybe it doesn't make sense to go this, but I would like to use this. So all I did now is downloaded here the copy YAML from the repository. And as you can see, it's here. And I can just then point to this and do some depend strategies, for example, because I say, okay, I really want to be sure that the copy only gets deployed when the cert manager is already deployed, because there are some certificates inside. So you can set everything up. You can also set specifically, hey, use this provider, because here I have server-side apply true. So that's one thing. So deployed the copy. And next step is then, we can also create via Pulumi some Kubernetes manifests or Kubernetes resources. So in this case, I'm using namespace. So I create for my Equinix Metal provider, I create now a specific namespace. So also, next point is I would like to create a secret. I'm using some kind of secret management, and I don't want to put this into my my Git repository, for example. Maybe I don't have a secret. Yeah, currently it is as it is. So I would like to use my secret. So here in this case, I need to provide my Equinix Metal API key. So I'm going to use the batteries included approach from Pulumi because Pulumi already has a secret manager inbuilt. So I'm using the Pulumi approach. So when we have a look, you can see it's already encrypted, so it's not visible. We don't have access neither to this, so I can just set this up and then just point here to the secret and then create a Kubernetes secret because we know that the KPI Equinix Metal cluster API provider is going to use this. And finally, we put everything together. So we're now deploying the KPI Equinix Metal. And also here, pointing here to the definition. Again, I'm not owning this, so I don't want to rewrite the stuff. If there's any changes, I maybe need to update my stuff. So don't take ownership of something you don't really could influence. But if I want to change something, yeah, that's the way. So again, pointing to my manifest file, and that's it. So now I can say Pulumi up. So that's the command to see and deploy. I already deployed this because we don't want to spend too much time on the deployment process. But as you can see with the Pulumi app, it's now running, checking against my local kind cluster. And yes, of course, there are no changes. So I don't want to perform the update because there is no changes. So, okay, so have a look into our cluster. How does it look like now? So I share screen and okay. So, okay. Kind cluster, I mentioned before, everything is deployed here and we see that the API provider is here. Everything is running as it should be. So that's completely perfect. This is also deployed very fine. Okay, so now let's deploy a cluster or using our setting. So let me stop this one and go back again to my code. So everything is deployed, all the controllers and are up and running as we could see. So now we would like to deploy an Equinix cluster. So there are some definitions, and in this case, I wanted to show you how to use our system of component resources. So what I'm creating now, I created now an abstraction. So I created now here a component resource called Equinix cluster. This is not something you get from Pulumi. You can set this up. I defined the interface to this component resource. I said, okay, these are the properties my folks can change. So if the development team, for example, I share now this component resource via our internal npm.js, and there's a documentation for this. So they say, okay, I don't want to run the definition of the KPI stuff on my own, but I would like to deploy the stuff or I would like to create a new cluster. So they can download this now via npm.js into their own Pulumi program and can then change some of the properties here because I defined here the properties. So Equinix cluster, as you can see, the namespace, the Kubernetes version, some defaults and so on. And here's all the magic now inside. So here I really went through and created now specific custom resources here with all the settings, everything related to create now here the resources needed for spinning up with the cluster API and cluster on Equinix. And as you see, what I mentioned before, I created now here the abstraction for the people, so the people don't need to think about, do I need a control plane? What is the properties? And so they can just use it, for example. And if there's a change, I can add this. Okay, so how does it look like in action? So I will take now, because folks are like, okay, there's so far, but what is the benefits? So let me take out now one resource. So I created here one resource, and we can say now, const e equals 0. Just so just want to create one cluster. I could remove the E, so because I'm too lazy now to remove this, and give it some meaningful stuff. So I would, for example, just use an Equinix cluster, and I do now a Pulumi app. Pulumi app will always execute also a preview, and I can see that the changes happens. And yeah, we can see now it's going to create now all the resources for me because I created the component. I have a specific name and the number. So now I created here, when I execute this, the manifests get deployed to the Kubernetes cluster, to the kind cluster, and then the operator kicks and create the stuff. So that's one part. And now we can leverage now the programming language part. We can say, okay, hey, why not creating a loop depending on whatever's going on? So I could now say, hey, create, please, 2 cluster. So let's stop this. And now we should see in the preview. Let's go. Always the way. And now we can see it creates going to create now 2 clusters via the cluster API. See all the definitions, they have unique names now because I set everything up, and I will get now 2 clusters. And now we don't need to talk, you can think about this in your development part. You can say, okay, I can put easy conditions inside, I can use different loops, I can get maybe the values from a database, from a YAML file, whatever, I collected the information. So everything is now possible. So we leverage now, we blend it in now, the Pulumi creation of resource with the programming language part, and we get all the time the feedback from Pulumi users like, hey, using a loop or using a condition is so much relief because now I can just loop through the stuff or just do some additional stuff and remove properties and so on. So very, very cool and very easy. So let's run this now for one. Okay, so let's give it a hint, and then we can. So I say yes. So let's fingers crossed that everything is working and the demo gods are happy. I forgot to give some gifts for the demo gods, so hopefully they help us. So it's going to create now the resources, as you can see. That's fine. So the resources are created. Let's have a look on our cluster, because that's what we would like to see also on our cluster. Where are you? You are here. So share. Okay. So let's have a look. Where are you? No, you are not here. Somewhere should be the cluster definitions. Okay. Okay, he detects that something gets deployed. That's fine. So let's have a short look on the console. Okay, now I changed to the console, so you can see that I'm not. Everything is working as expected. So let's share my screen, and I share the Chrome tab. Okay, so we can see now that the cluster here, or the virtual machine, gets now deployed. So we see now Equinix cluster 0 control plane. That was the definition I just gave, using here the server type, getting an IP address and the state it's going to deploy. So yeah, that takes a little bit of time, but yeah, that's what I wanted to show. I already deployed also another one using the approach, but that's something. Okay, so this takes now time, because it's not only the control plane, it's going to deploy also the worker nodes. But let's head over to the code. Now I lost the code. Okay, here. So as you can see, the Equinix cluster, we saw it in the console. It has a specific name. It created now the resources, and let me see if. Oh no, I don't want to spend too much time on this. Okay, that's it from this part of the demo. We talked about the config management. I showed you how to create an abstraction with a component resource. I use a reusable one. You can now share this on the language specific part, or we have also a concept of multi-language components. So that's completely, you can write it in one language and deploy it in a different language. Okay, let's head over to our slides. Okay, so demo, that's the link. Maybe we can share this also afterwards. Q&A. Do we have any questions?
Yeah, I think it's been great. I liked seeing that we're also leveraging some like Kubernetes control plane stuff here to enable things. And yeah, I think it was great seeing the demo, and I like seeing the different ways that Pulumi leverages like natural programming language, or I guess none of them are natural, but leverage programming languages in full, as opposed to just a pile of YAML configs. It was really neat.
Yeah.
Thank you so much for your time.
Yeah, thanks for the invite, and everybody watching, have fun, and see you soon. Bye.
Yeah. Bye. And I loved the intro on what is InfraCode too. Maybe we should have started with that one, because we forget, right? It's easy to forget as engineers that everyone has to start somewhere and learn what these things are. So that was wonderful as well. And thanks again to Engin for that.